So here we have a question again from Kinematics. A bicycle moving at 9.5 meters per second accelerates at a rate of 2 meters per second squared. How long does it take for the bicycle to cover a displacement of 25 meters? So again, these kinds of questions, this is all linear. So everything is happening just in one dimension in a straight line. So we're going to define to the right as the positive direction. So any forward or positive quantities, that's the direction it will indicate, and negatives would indicate anything in the opposite direction. So as always, let's write down everything we've been given. It says that it's moving at 9.5 meters per second and then accelerates. So that 9.5 is our v1. That is the initial velocity. Acceleration is given as 2 meters per second squared. It's asking how long, so delta t is something we need to find out. And it says that the displacement is 25 meters. And it's assumed that this is 25 meters forward. So we need to find one of our kinematics equations that has these four variables in it. So we can use this one. Delta D equals V1 delta T plus 1/2 A delta T squared. So let's sub in everything that we have here. 25 equals 9.5 delta T, 2.0 delta T squared. Okay, so now delta T is the only variable that we don't know, but we've got a delta T squared over here, and just the delta T over here. So we're not going to be able to combine those into one to isolate delta T. So how can we go about solving this? Well, this is actually just a quadratic equation. Delta T is just the variable, where normally we would have an x squared, and here's just an x. So we can solve quadratic equations just using the quadratic formula. So usually that's when we would have it written in this form. 0 equals ax squared plus bx plus c. So if we can rewrite this equation in that form, we can use the quadratic equation. So let's rewrite that. Let's put the delta t squared part first. Now this is just going to be 1, because here was 2 times a half. Next we put the delta t, and then we need to get rid of that 25 on the left side by subtracting 25 from both the left and right, which gives us this. So now this is our A, this is our B, this is our C, and we can just use the quadratic formula. So now delta t equals negative 9.5 plus or minus the square root 9.5 4 all over 2 times 1. Now if we go through and crunch those numbers, we should get two answers. So delta t either equals 2.1 seconds or negative 12 seconds. Now in physics, we would call this inadmissible because we're not concerned in negative time. That means we're going back in time. We're concerned about realistic things like the 2.1, where it's a positive time. So this would be the final answer that we would state. Delta t equals 2.1 seconds.